All right, I want to start lab 2 by actually building the circuit in MultiSim and then calculating it, and then I'll come back with part 2 where we're setting it up on the breadboard. So to get to MultiSim, I go to lab.devry.edu, or I click on the link in the lab overview tab under modules. To build my circuit, I'm going to come under sources, and I want a DC power source, and I'll drop it there. Then I want a resistor, so I'm going to click here under group and go to basic, and under basic I'm going to come down and find resistor, and for this particular one I need 1K. Then I also need a ground, so I'll go back to sources, and under power sources grab my ground, and place it there. Now for right now I'm going to connect these together. Oh, and I'm going to double click on my battery and change that to 5 volts. 5 volts, 1 kilo ohm, and I want to calculate the current. I equals V over R. So 5 volts divided by 1 kilo ohm. Five divided by 1 EE3. So I've got 5 milliamps. 1, 2, 3. That makes it 5 negative 3, or 5 milliamps. All right, so how do I measure that in this circuit? Now, this is a complete circuit. We have a source and a load and a path. All right, our source is the 5-volt battery we have here. Our load is the 1K ohm resistor, and the wires are used to complete the path. Since there's only one component in this circuit, all 5 volts are being used by that 1 kilo ohm resistor. So we should see the 5 milliamps through the circuit. Okay, to measure that, I'll bring in my meter. And I think there is an Agilent multimeter over here. If you want to use that one, we can. I'm not sure that's any closer to the one you have, so if you're working on campus, you would have one that looked like this. I think for us, ours is actually closer to the virtual meter. Okay, measuring current can blow the fuse in your meter if you don't set it up properly. If you come and set it up like this and turn it on to measure current, you're going to blow the fuse in the meter. Okay, so make sure when measuring current, you always make a break in the circuit. If you think about current as the flow of the electrons, then you have to get in the flow of electrons to be able to measure the flow of electrons. So that was what we do with the meter here. As we connect it, we make it part of the flow of the circuit, and then we can measure the current. My analogy for this is a cop trying to run radar on a highway. I live in Atlanta, so 285, 85, 75, 20, 400, take your pick. If they're trying to run radar and they're sitting up on the bridge, they're not going to be able to catch you if you're going really fast. Now, they can have the guy in front of you catch you, but that's a different story. They can't catch you. If they want to catch you, they have to be in the flow of traffic to be able to catch you as you're speeding. Not be able to track you. For that, they got to be sitting on the side of the road so they can measure your speed. And that's actually kind of what we're doing here. We're sitting on the side of the road making a measurement in this path. All right, so I got my meter hooked up. Now I'm going to turn the power on. And there's my 5 milliamps that I'm expecting on my multimeter. Now another thing that I want to do before I actually hook up my meter to measure the current in my circuit, I'm going to do two other things with it. So I'm going to back up a second and bring my meter back in, and I'm going to hook it up here and measure my resistor. And then I want to hook it up here and measure my power supply. Oh, 5 volts. Okay, so now I'm going to come back with part 2 and do all of this on our ML 2010 trainer.